Hi, I'm Chala Mahera, and today I'll be discussing the task 6.1p polymorphism. First, we'll be talking about what is polymorphism. Polymorphism is a key concept in object-oriented programming that allows objects of different classes to be treated as objects in a common superclass. In this program, polymorphism is implemented through method overriding and with the use of base class bird to interact with derived classes, duck and penguin. But if we go to the bird class, this is the bird base class, and when we go to the duck subclass, we have the subclass duck and the base class bird, and penguin is also a subclass. We have the subclass penguin and the base class bird, and within the bird base class, we have virtual methods fly that can be overridden by the subclasses penguin and duck, and the the subclasses override these methods to provide their specific implementation. For example, this fly a virtual fly method says flap flap flap, while within the penguin method it is saying of override method, penguins cannot fly. And the toString method is a override method in the bird class. It's saying the bird code and the name, and it is being overridden in the duck class with a duck named and the duck name with the size and the kind. Now, if we go to class program, we have created a list of birds, and if we go a bit down, we can see that we have created a list of bird over here, and this list bird is created to store objects of the base class bird and derived classes penguin and duck. When we are iterating through the list of bird objects, each object's overridden methods are called, and this demonstrates runtime polymorphism where the specific implementation of the method is determined at the runtime. Now, if we talk about the method overriding in this program, method overriding is when the derived classes, which is subclasses, is providing their own implementation of a method that's already derived in the base class. It requires the method in the base class to be marked as virtual, and the overriding method in the subclasses need to be marked with the override keyword. As you can see, we have the virtual keyword here uh, for the fly method, and here we have the override keyword to override the virtual method in the penguin subclass. Also, when we call the fly or toString methods on a bird, penguin, or duck object stored in a list bird, the appropriate overridden method is for the object's type is executed. Now, if we talk about the covariance which we have used within this program, covariance allows us to assign a more derived type like duck to a more general type like bird through interfaces or delegates. In this program, covariance is used with the INMT interface to treat a list of duck objects as a collection of bird objects. So you can see we have created a list of duck here, and we have INRBT bird here. Here, the list of ducks is upcast to the ionable bird, and the ionable bird is then added to the list bird using add range. And when we are iterating over the list bird, the correct overridden toString method for each duck object is called, demonstrating the combination of covariance and polymorphism. So, in summary, polymorphism in this program is showcased by treating penguin and duck objects as bird objects, calling overridden methods, and method overriding allows penguin and ducks to provide their own implementation of fly and given within the base class, and covariance is used with INOVLT to handle a list of more specific types as a more general type. And we can see the program run, and you can see that it has, we are calling the methods here, and it has given us the correct output according to the called method. As you can see, we are calling the fly method in the bird class, and with the toString method, as you can see, it has given the correct methods. We're saying flap flap flap. As you can see, our program is working as expected, and we have discussed about polymorphism and covariance and method overriding and virtual methods. So that's it for my discussion. Thank you.